Hello everyone. Today I'm going to be going over two of the statics problems that can be found in your textbook. And so the first problem I wanted to go over includes the following. The crate has a weight of 550 pounds. Determine the force in each supporting cable. Now, for most of these 2D/3D problems, one of the first steps that you want to start with is by creating a free body diagram. And so here I've illustrated two free body diagrams, since you're not only dealing with the point at A, but you're dealing with the free body diagram of the crate itself. This will help you in the long run, as you will find that FAD is equal to the force of the weight, which not every problem is going to be as simple as this, but in this case it ended up working out pretty well, and so your FAD is going to be equal to 550 pounds. But we're worried about also the other supporting cables. So for step 2, we need to find the components in both the X and Y directions of the other supporting cables. So we will start by looking at the one with the angle. Everyone knows that this is just trigonometry here. We can find that FAB in the X direction is FAB cosine 30 degrees, since it's adjacent over hypotenuse. And so for the Y direction, it's just going to be equal to FAB sine 30, since it's opposite over hypotenuse. The other side is not as easy, since it doesn't give you an angle exactly, but we know from class that you do 3/5 is equal to what FAC in the Y direction is over the hypotenuse, which is your FAC. And the same makes sense for 4/5 equals at FAC in the X direction over FAC. So once you get all these components here, you can then move on to step 3, which is finding all the forces in the X and Y direction and summing them up. So we're going to start with the forces in the X direction, because there are less values that you need to deal with. So first value you will plug in is your negative FABX, since it's going in the negative X direction, plus your 4/5 FAC here, since it's your other X component. And so we can change this value here to what it is up here, which is FAB cosine 30. And once we plugged it in here, it's basically simple algebra. You bring this to the other side here, or however you want to arrange it, to where you will divide cosine 30 degrees over, and you should end up getting your FAB as 0.9238 FAC. But that is just one part of this step. We have to go on to the Y components here, and we will plug them in as FABY, since it's going in upward Y direction, plus 3/5 FAC, which is what we just got from up here. But now we've added the force of the weight, because that's your other Y component, but it's acting in a negative Y direction, so we have to acknowledge the negative here. Obviously, we can just plug in the value here, what it is, which is shown above. They give you the weight. So what's cool here is you can actually plug in what your FAB you just found in order to get common variables. And so you will multiply 0.9238 by sine 30 degrees, and it will change it to 0.4619. And then you could just add these two numbers together, and you should end up getting 1.0619 FAC is equal to 550, because we basically brought it to the other side. Again, simple algebra, you will divide this number over, and you should end up getting, as your FAC, 517.9, but we need it in 3 significant figures, so it will be changed to 518 pounds. That's not the last part, but this helps with the last part, because you can basically just plug in what you just found into the FAB formula. But you can't use 518, you can't use 518 pounds, because you may end up getting a rounding error. So you have to use what it was originally, which is 517.9. So all you will do is you will multiply 0.9238 by 517.9, and your FAB should end up getting 478.4, and rounding it to 3 sig figs, it should end up being 478 pounds. And so for problems such as these, it's usually best to just draw your free body diagrams first, kind of get a foundation as to what is really going on in the problem, and try to visualize what values you really need to find. And as you just go through the motions of finding the components and getting all your values in the x and y direction, it should really help out when you get to plugging things in, and it helps to define a lot of your problems a lot faster. And so that is the end of the first problem.